The sample preparations becomes very important, and specifically when you're using additives like surface tech fibers, then there are some standard procedures that you need to follow in order to reproduce a mix in the lab that is as close as possible to what you're going to be producing in the field. That being said, those standard procedures were developed based on experience and knowledge on the field procedures, and then it's highly recommended to follow closely those procedures while preparing specimens for your testing. The first thing you have to basically do, make sure that your fibers are very well dispersed into your mix when you're doing that in a lab. You don't want to basically end up with the clumps of the fibers in the lab, which doesn't represent what's happening in the plant-produced mixtures. That's why we go through that procedures of properly weighing the materials and dispersing that materials, and then following specific steps on how to introduce into the aggregate before introducing your hot asphalt binders. While you're going through that process, it's very important to maintain the temperatures of your mixings. And also what the experience showed, that the bucket mixers is the right way to mix your fibers. That helps you to disperse the fibers rather than, clumping the fibers into your mix. So obviously, Surface Tech developed standard procedures. There's a written procedures, and there's some videos that walk you through the steps. So for us, our first step is to educate our graduate students on these procedures, do trial batches, and get very familiar with the process. It does take a little bit of time and an experience to get comfortable with the mixing procedures. And then I just want to also point out that our lab is accredited by AASHTO Resource. So that is also very important for us to make sure that the procedures that we follow are, the proper methods and following the proper standards. What we recommend is always to have two students working together rather than, just one person. Because of the handling the materials and then the way you want to introduce the fibers into your mix, you're going to need another hand while doing that in a lab. So as a program, the Pavement Engineering and Science program at the university, obviously we do extensive research in the asphalt materials for different products and different additives. And you can see here behind me, right, all the different types of additives and product that can be added to the mix. And the aramid fibers is one of them, working with Surface Tech to evaluate the performance of fiber reinforced asphalt mixtures. One specific aspect, there's a lot of studies that has been completed that showed promising results for the fiber reinforced asphalt mixtures. One specific aspect that we are looking into it is related to durability of the mix and the moisture damage resistance of the fiber reinforced asphalt mixtures. So we're trying to basically reproduce those fiber reinforced mixes in the lab and compare them to the traditional asphalt mixtures by subjecting them to multiple freeze-thaw cycles and pushing the limit, if you want, on the moisture resistance evaluations of these asphalt mixtures. Right now, there's a big push into the sustainability and use of sustainable materials. Our understanding of sustainability is not only related to the low carbon transportation materials, but also the performance. A material or a mix is not really sustainable if only you're reducing your low carbon emissions early on, but then it doesn't last as anticipated. And a good potential here that we have with the aramid fibers is that if we can get the pavement performance and the extended life in the pavement performance while reducing early on your carbon emissions, then it's a win-win situations. And that's obviously what's the real definition of sustainability. As long as you don't jeopardize performance, right, and then you reduce the carbon emissions, that's basically what the real definitions of sustainability. We're here today at the University of Nevada, Reno. I'm a faculty in the Civil and Environmental Engineering Department at UNR, and I'm part of the Pavement Engineering and Science program, one of the top programs in the United States and nationally that deals with the evaluations of asphalt mixtures. In our program, we have three faculties, obviously myself, the program director, Professor Peter Sobali, and Dr. Adam Hand. as well as we have our research scientist and lab manager, Ashraf Al-Rahiji, and then also our graduate students from master and PhD students. In our labs, we do advanced evaluations of the asphalt mixtures. We start actually with the raw materials, from the aggregates, the asphalt binders, the additives and so forth, all the way to the asphalt mixtures evaluations. And we go extensively by evaluating the mix for different temperatures, for different loading frequencies and so forth. But then also we have one extra step. We have also full-scale pavement testing facilities. So all what we do in the lab, and before we deploy it into the full productions, there's that intermediate steps where we have a full-scale, we call it a pave box, test facilities where we can build pavements where you have a subgrade, a base, and asphalt layers, and we have a dynamic loading systems where we can subject the pavements to different type of loadings and measure the response of the pavements and evaluate what really, or confirm what we observed in the laboratory at a larger scale. When I was introducing the program, we do research for national institutions. We do as well research for state DOTs, State Department of Transportation, local agencies. But at the same time, also we work very closely with the industry. And one of our partners that we have cooperative effort with is Surface Tech, where we get to work closely with, in that case, with Surface Tech to evaluate their products and basically disseminate and deploy the findings of our research. So when we look at the products, we basically develop an experimental plan that we work closely with the company, that we end up evaluating in the labs, extensively looking at the different aspects of the products. In the case of the Surface Tech, we are focusing mainly on the moisture damage aspect of it, because it's basically, if you think about it, once you have moisture damage, right, that's it. You're gonna get the rutting, you're gonna get the cracking, you're gonna fail in all of these distresses. So if we can improve on the moisture damage aspect of the asphalt mixtures, then definitely we're gonna improve the pavement performance and we're gonna be more sustainable. So we have a program running right now going on, and then we are actually in the phase of sampling materials and evaluating the raw materials in the lab and then producing the mix designs. And the next step is gonna be evaluating those different mixtures, the fiber reinforced and the control asphalt mixtures in the laboratories, and then run comparisons between the two. We share all our results back with the Surface Techs, and then we discuss, our findings and observations with the industries. And then obviously our aim is to disseminate that information through, publications, conferences, journal papers, and so forth. It's important when you have a product, it's beyond the typical the aggregate and the asphalt binders, right? To start with the lab evaluations, to understand, right, the behavior of the materials in the laboratory. And that's where we started, right? That sampling and the mixing procedure and everything is very important, so that we can reproduce what's happening in the field. And then those findings and results also, they have to relate to the industry, okay? So for us, the good starting point with the Surface Tech is to really pick on actual materials available on the mix design that are typically used, common materials, so that we can start with something that the industry is familiar with and take that products and see with the fibers how we can improve the performance of those mixtures. Sometimes it's not about only improving, but maybe helping those mixtures, because there are some mixtures that may be struggling with the moisture damage, right? And this will create a very good opportunity with the fibers to help those mixtures so they can become up to the standards of the state highway agencies. And then it's basically the findings that needs to be deployed and then introduced to the industry. And when I say industry, I don't mean only the contractors, right? The contractor, the agency, the consultants, everybody needs to onboard. If you want your technology to move forward and be implementable, right? Everybody, all the stakeholders that needs to be involved in that process. And that's why it's very important, any research, to communicate that back and the findings with the industry and get feedback as well with the industry. So we are lucky that with the Surface Tech, they have a good backgrounds from the field, so they can also translate and then provide feedback and input into our research about what is really happening in the field and how we can really bridge the gap, if you want, between the lab and the field experience.